Question number 2. An experiment to find the internal resistance of a cell of known EMF is set. To following experiment is following equipment is available. So you have a cell, you have an ammeter, you have a 10 ohm resistor. Draw a suitable circuit diagram that would enable the internal resistance to be determined. So you need to find out the internal resistance within the circuit. Okay. So how do you do the internal resistance? See, you create a circuit like this. See, what is that you need? You need a battery, and then you need to have an ammeter to find out what is the current. And this in turn is connected to a resistance like this. Okay. So this circuit is sufficient for you to calculate the internal resistance. How, why, if you ask me, it's quite simple. See, for example, if I is the current passing through it, R is the resistance over here, and R is the internal resistance of the battery. I can now say I can be determined using the ammeter. I into R plus R should be equal to V. Right? V is the potential difference. Since the value of I can be measured using the ammeter over here, R is known to you here. This R can be determined. This V is nothing but a battery that you have here. This value of the battery is already given there. So easily you can determine. It is the experimental setup that you actually need to determine. Then it is noticed that the resistor gets warmer. Explain how this would affect the calculated value of the internal resistance. Now what happens? As time proceeds, the temperature increases. When temperature increases, what will happen? Resistance will increase. That's what it says. Resistance gets warmer. So as a result of it, what will happen? We know V is equal to I into R plus R, right? Or I will write this as IR plus I into small r, right? In other words, okay, or maybe I'll just write like this itself. I can now write I is equal to V divided by R plus R. In other words, the value of I now reduces. The value of I reduces because the value of R is increasing. Okay, so naturally, the value of I reduces, value of R is increasing. So what will happen to this one? So V minus I into capital R is equal to I into small r. Okay, that's what I get from here. So therefore, now you see, when this value increases, so let us say, for example, if this is 5 over here, and this was initially when you started the circuit, this was 2 here. So you would have got 5 minus 2 divided by I is equal to R. That's what you would have got initially. Okay, let us say at t equal to 0. But after some time, let us say the value of R increases. When the value of R increases, what happens to this product IR? IR will also increase, which means this will no more be 3. This would have become 5 minus 3 divided by I, right? 2 would have become 3 over here. So therefore, this would have become 3 by I, this will become 2 by I, right? So as a result of it, what will happen to R? R would be much reduced over here. Okay. So therefore, the R calculated would be larger as compared to R experimental. That's what happened. So therefore, now this is for 3 marks. So what you should do is, the first one is, you should say, as time proceeds, resistance increases. Resistance gets warmer means this for 1 mark over here. The second one is, you should write this experiment, you should write this expression, and you should get this one here. Until this one you get, you should mention that the I reduces. So 1 more mark over here. And finally, you should mention that R is equal to so much, and as a result of it, calculated internal resistance will be larger than the experimental internal resistance. So this is how it gets affected. Okay. So if you write all these 3 points, that you will get completely 3 marks. If you just stop until here, you will only get 2 marks. Even if you write this one, if your conclusion is not there, you will not get that mark. Let us move on to the next. Outline how using a variable resistance could improve the accuracy of the value found out for the internal resistance. So what does he say? Instead of using this 10 ohm resistor, see, you are putting a standard 10 ohm resistor. Now I will put a variable resistor. It means how you put the battery once again like this, put the ammeter here, and then you put a variable resistor over here. Now, how does it improve the accuracy? That's what's the question. See, here I was doing only for 10 ohm. Now, if I put a variable resistor here, I can do it for 5 ohm, 10 ohm, 15 ohm, 20 ohm, 25 ohm. I can vary the resistance here. As I vary over here, I get multiple trials. When I do multiple trials, multiple observations, what happens? So, you can actually get a random error to be reduced. Random error will be reduced. The first point we get. Okay. The second point. What is the second point we can say? We can say, as we have this one over here, so the value of R will be more accurate. Why should it be more accurate? because you are doing multiple trials, you will get some value of R every time. That value of R, you will take the average. For example, if I get the first one, only one time when you take this value, the value of R could be something like, let us say, 3 ohms. If I'm doing multiple trials, multiple observations, sometimes I get 3, 3.1, 3.3, 2.8, 2.7, 3.3, 3.4, and so on. Now I can take the average of all of them and I can get a particular result. And this result would be more accurate as compared to only one result, because you are not looking for the variations. If you take up only one resistance, you should always do something like this. Next one, I think we have come to an end to this. Let us see the next question in the next video. Thank you.